to the Math is Right, the newest, coolest game show around. In this show, the contestants will be asked a series of questions related to the history of mathematics. At the end of each round, the contestant with the highest score for that round will be given the chance to sing one of their favorite math songs to earn extra points for that round. The player with the most points at the end of the game wins. First, let's have our contestants introduce themselves.
Hi, I'm Ryan. I'm a graduate from Cambridge University, where I have received 20 degrees, or pi over 9 radians. I just cracked myself up. Anyway, I have 20 degrees related all to math, and only 160 more to go before I'm a triangle.
Hi, my name is Elizabeth Marie Nicole Jessica Darcy Miranda Cook, but you can call me Liz for short. I love long walks on the beach and writing math problems in sand.
How nice.
Very nice. Hello, my name is Diane, and I'm a mathematical hair genius and use my skills to make some amazing three-dimensional hair designs.
My friends call me Dr. Bose. I have a PhD in mathematics and wrote the whole series of Mathematics for Dummies.
Okay, now that we know our contestants, which is a lively bunch of that, let's get started. I will start our first series of questions here. The category is entitled, To Math or Not to Math? That is the question. Question number 1. Who wrote Fermat's last theorem?
Ding ding. That would have to be Pythagoras. You know, he was really good at those right triangles and everything. Who would have guessed that? B squared plus, a squared?
No.
The answer is obviously Pierre de Fermat.
Correct. And what does Fermat's last theorem state?
Ding!
Liz.
Fermat's last theorem states that there's no three negative integers a plus b and a, b, and c that can satisfy the equation a to the nth plus b to the nth equals c to the nth for no greater than -2.
Wow, that was very, very close. But no.
She meant to say there's no three positive integers a, b, and c that can satisfy the equation a to the n plus b to the n equals c to the n for n greater than 2, not negative.
Wow, that is correct. So let's keep moving with these questions. What two theorems in Fermat famously known for?
Bing, bing.
Diane?
Well, obviously, he wrote more than 2 theorems. It could be any of them. With my expertise as a mathematician, I'm here to say that all theorems are important.
Oh, time's up. Do we have any real guesses? Lisa?
Yes, that would be the little and less theorem.
Oh, that is correct again. Thank you for keeping your answers concise. You'd be surprised how many mathematicians can just go on and on with their answers. Next question. Since math was only a hobby for Fermat, what was his actual occupation?
Ding ding ding. I know, he was well, it had to be something awkward, those mathematicians.
Surprisingly, he was a lawyer.
Ding ding ding! There you have it. Yes, he was a lawyer. Lisa is on fire with these questions about Fermat. Let's see if she can continue her streak. Next question. What famous book written by Diophantus inspired Fermat to work with his number theory? Lisa?
Arithmetica, Math America, my 2 favorite things.
That is correct, although I'm not sure that America was actually a part of the book. Anyways, the next question you are going to have to be fast. Fermat actually scribbled on his greatest discoveries, now known as Fermat's last theorem, onto the margin of Arithmetica. True or false?
Ding! False.
Incorrect. Lisa?
True.
Oh, well that is an obvious now, but since I'm feeling generous and I'm America's favorite game show host, I will give you the points anyway.
That's not fair.
Well, life's not fair either, but let's go to a commercial break.
There was a great mathematician named Pierre de Fermat. He discovered new levels of calculus, like infinitesimal and differential. He also had a huge impact on number theory and named 2 theorems after him. And so this song I sing, oh, Pierre de Fermat, with his little and less theorems. He wrote many letters that contained no proof, so it was hard to believe his work was true. Oh, Pierre de Fermat, why'd he have to be so stubborn? There's probably many math facts we'll never know because he kept his math all to himself.
Alright, and now we're back. That was some great singing by Dr. Bose, wasn't it? Alright, let's move to this next round. This round will be focusing on good old Fibonacci. So let's dive right into the questions. Let's start with an easy one. Question 1. As you probably know, the Italian mathematician Fibonacci went by the name Fibonacci because of his father's trade. What is Fibonacci's real name? Lisa.
Leonardo, DiCaprio.
What? He's an actor? That mathematician too? Wow.
No. The correct answer is Leonardo of Pisa. Kind of sounds like the Leaning of Tower of Pisa. Well, I mean, at least that's how I remember it. It's definitely one of my favorite mathematicians, and he was definitely not an actor.
Well, yes, that is correct. Maybe we should just keep moving with these questions. Next one. Fibonacci was able to introduce what number system to Europe?
Bing, bing, I know. That would be the Roman numeral system.
Again, that's an excellent guess. Yet not correct answer. Anyone else?
Ding ding. Yes, of course. That'd be the Hindu Arabic number system. You know the number system we use today, 1, 2, 3, 4, and we can't even hit a maximum number. I just get all flabbergasted thinking about it.
I'm trying to run a game show here. Let's keep moving so that we can get done. The Fibonacci numbers are something that all mathematicians are familiar with. Can someone name the first 8 Fibonacci numbers for me?
Ding, ding, I can. 0, 1, 2, 3, 4, 5, 6, and 7.
Wow, that was another excellent guess. Especially since those are the first 8 numbers from the Hindu Arabic number system that Fibonacci worked with. Someone else, please.
Ding! I know these. 0, 1, 2, 3, 5, 8, 13, 21.
Another excellent guess. However, there is something missing here.
Ding! Yep, you're absolutely correct that there's something missing, and the answer would be 0, 1, 1, 2, 3, 5, 8, and 13. Gotta watch out for that double 1.
That is absolutely correct. Those double ones really are a killer. And now, on to the 4th question of this round. What was the title of Fibonacci's book that was published in 1202 in order to spread the knowledge of the Hindu Arabic number system?
The Elements.
Sorry, wrong mathematician. Other guesses?
Ding! Liber Abaci.
That's all you have to say?
Yep.
Usually you just keep talking. Well, anyway, that is correct. Good job. And we should probably move on to the 5th question now. The Fibonacci numbers are often seen in nature. On a flower, what piece would you expect to have a representation of the Fibonacci numbers?
Ding! The stem.
No. There's only one stem. Certainly it has to be the petals.
Correct! Let's finish up this round with the 6th question, why don't we? Fibonacci discovered the Fibonacci numbers through a problem in his book, Liber Abaci, that dealt with what animal?
Ding! Ding! The squirrels.
You should think so with all the squirrels around here, but no.
Ding! It's rabbits. You know the old phrase, they're multiplying like rabbits? Well, Fibonacci really did multiply using rabbits.
Wow, good job, Ryan. Well,
Yeah.
that concludes this round, so let's go to another commercial break, why don't we?
Fibonacci, a mathematics genius, you know he is. He found a pattern in nature, Fibonacci. Write me a theorem tonight. Fibonacci, he used some bunnies to do some math with class. Hero Liber Abaci, Fibonacci. Write me a theorem tonight. Think of all the math we've seen. Think of all the Fibonacci numbers we haven't seen. If you could just believe that there is an infinite amount of numbers you see. Fibonacci, he gave us Arabic numerals too, for you. Math just wouldn't be the same. Fibonacci, write me a theorem tonight.
Alright, and now we're back. That was another great performance by our man, Ryan. So, let's move on to the third round, why don't we? Euclid is the man who proved that it is impossible to find the largest prime. Now, let's see how impossible this round is for you guys. So, first question. By what other name is Euclid known by the world of math?
Ooh, I know. Master of Conics.
I'm sorry, but that is incorrect.
Ding! Father of geometry, obviously Lisa. Maybe you have heard of Euclidean and the non-Euclidean geometry.
Whoa, whoa, whoa. Okay, let's settle down now. There is no need to fight here, okay? So, I think that's correct, so we'll go with the next question. What famous series of books did Euclid compile?
Ding!
Sorry.
I have this one. It's Liber Abaci, translated to English as a book of calculation.
That is incorrect, Ryan. I am sorry. Does anybody else have an answer?
Pick me, pick me.
Well, fine. Diane.
Elements is actually a series of 13 books. That's a lot of books.
Yeah, sounds pretty unlucky to me. Ha! On to question number 3. What were the two types of math that Elements focused on?
Ding! Addition and subtraction.
Okay, Liz, Euclid was one of the most famous mathematicians of all time. Do you really think he wrote 13 books on addition and subtraction? I mean, come on.
Ryan, do you know the correct answer?
Yes, I do, John. Elements focus on both geometry and number theory.
Excellent answer. Next question. Many things were named after Euclid. What does Euclid's lemma state?
Bing, bing, I got this.
All right.
If a natural number divides the product of two numbers, it must divide at least one of them.
Hello, Diane. 4 does not divide 6, and 4 does not divide 10, but 4 divides 60, so obviously this only works for a prime number.
Wow, that was a little sassy, but nice work, Lisa.
If a prime number divides the product of two numbers, then the prime number must divide at least one of the two numbers.
Correct again. Now, next up, number 5. What is the name of the algorithm that is named after Euclid?
Euclidean algorithm. Try to challenge us a little bit, John.
Whoa, okay, well then. What is one of the Euclidean algorithm? What is of the Euclidean algorithm?
Me.
Liz?
To determine the greatest common divisor.
Yes, Liz, you are correct. So let's now move on to the last question of the Euclid section. What does Euclid's first postulate state?
Ding, ding. It's something about lines, but I can't remember what it is.
It is about lines. You are right. But what about them? Oh, Lisa.
I know, given any 2 points, such as A and B, there's a line AB which has them as their endpoints.
Okay, good job. That finishes this round up. So let's move on to another commercial break to give our contestants a chance to cool down. Who knew math could get so heated? We'll be right back after this.
Reading through the elements, postulates you will find. They will start making sense once you read all 5. This geometric treaty brought math to everyone. What fun it is to read and sing a math song tonight. Oh, axioms, theorems, constructions are so fun. Oh, what fun it is to sing about a math genius. Oh, axioms, theorems, constructions are so fun. Oh, what fun it is to sing about a math genius.
All right, welcome back. Another great performance by Diane. So, moving on to our fourth and final round. Let's make this the speed round, why don't we? Alright, question number 1. During what period did Pythagoras live?
Ding! Can I have a definition of, please, maybe the language of origin?
What do you think this is? The spelling bee? What mathematical time period did Pythagoras live during?
Ding! Oh, the Greek period.
Question number 2. Where was Pythagoras born?
Ding, a long time ago in a galaxy far, far away.
Nice. And extra points when?
Ding ding! Island of Samos, 570 BC.
Okay, good. That's another correct one. Moving on. What is the origin of his name?
Ding. Yes, well, this origin is at the location where the a-axis and the y-axis cross.
No. Not on a graph. What is the origin of Pythagoras' name?
Ding ding ding!
Liz.
His name is associated with Python Apollo, meaning he spoke the truth, no less did Python.
Wow, that is correct again. Liz is on fire this round. Let's move on. What is his number 1 mathematical discovery?
Ding ding ding!
Liz.
The Pythagorean theorem, a squared plus b squared equals c squared. But did you know that some historians say that Pythagoras never actually dealt with that math himself? In fact, it was his followers, the Pythagoreans, that came up with the mathematical ideas.
Wow, thank you for that awesome detailed answer. Question number 5. What were his musical discoveries?
I'm musical. I can sing. La 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 la.
Wow, I'm amazed. But can you answer the question, please?
Oh, Lisa, the real answer is he saw that musical notes could be translated into mathematical equations and realized that it was scientific law that allowed the music to be made. The lengths of the strings were proportional to the whole numbers.
Wow, we have another tally there for good old Liz. Question number 6. What are some of his religious beliefs?
Ding ding. I think he was like a cult leader.
Whoa, I don't know about that
I'm pretty sure he was the Pope.
one. Another close answer, but wrong again. Anybody else?
Ding, I don't know, I mean, he was probably religious, you know.
Ding, 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 ding!
Liz.
Actually, all of you guys, he believed in transmigration, which is the reincarnation of the soul again into bodies of humans, animals, or vegetables until it became immortal. So that means someday you might be a dog.
Wow, that is correct. Can anybody else give any other beliefs, possibly? Or Liz can take it again.
Ding, ding, ding!
All right, Liz.
He believed that all things are numbers and math is the basis for everything. He believed that the numbers have the personality, strengths, and weaknesses. The world depends on the interaction of opposites, and all members of society should observe strict loyalty and secrecy.
Wow, another point for Liz. This is a great round for everybody. Question number 7. Who was someone Pythagoras influenced?
Ding.
Oh, no,
Ding.
Lisa.
Michael Jackson.
Incorrect. All right, Ryan.
Plato?
Oh, wow, look at that. Somebody other than Liz. All right, so question number 8. What instrument did Pythagoras play?
Ding, ding, ding.
Ryan?
Piano.
No. Liz?
French horn.
Ding ding.
Wrong, Lisa, sorry. I was expecting the right answer from Liz. Sorry. Okay, go ahead, Diane.
I believe it was the violin.
Another
Ding, ding,
close one.
close, but the lyre.
Wow, there we go. That's the girl I knew. All right, number 9. What did he like to do in his free time? What was that, Lisa? Okay, Lisa.
Play golf.
Ooh, I don't know if that was invented back then, but close.
Ding.
Ryan.
He made math videos, obviously.
Ooh, he probably did back in his spare time. So, moving on. Anybody actually got the right answer?
Ding.
Oh, Liz.
Recite Homer and read poetry.
Wow, looky there. Would not have expected anything different. So, as you guys can see, Liz won this round. So, we're going to move on to the commercial break here, and we'll see you soon.
I got this problem in my head. I need my pen and paper. This is not a problem for me, Pythagoras. I got my brain to think and figure it out. I got famous and known for years. I don't care.
I love it.
I don't care.
I love it.
I got an A and B and C. I got 2 sides and 1 hypotenuse. different animal, but I'm still human. I like to speak Homer and write poems. Plato came from me, and he's so cool. You're from the future, but I'm from BC. I love math. I love math.
Welcome back. Well, that was an eventful game show, was it not? Well, while the judges are tallying up the scores, let's get a word from our sponsors. Prof. Chang's Mechanics. You break them, we fix them. On the first day of math class, Prof. Chang gave to me
The multiplicative identity.
On the second day of math class, Prof. Chang gave to me
The number that points to define a line.
And the multiplicative identity.
On the third day of math class, Prof. Chang gave to me
The number of understandable spatial dimensions.
The number points to define a line.
And the multiplicative identity.
On the fourth day of math class, Prof. Chang gave to me
The number of sides on a square.
The number of understandable spatial dimensions.
The number points to define a line.
And the multiplicative identity.
On the fifth day of math class, Prof. Chang gave to me
The number of platonic solids.
The number of sides on a square.
The number of understandable spatial dimensions.
The number points to define a line.
And the multiplicative identity.
On the sixth day of math class, Prof. Chang gave to me
The first perfect number.
The number of platonic solids.
The number of sides on a square.
The number of understandable spatial dimensions.
The number points to define a line.
And the multiplicative identity.
On the seventh day of math class, Prof. Chang gave to me
The number when you square root 49.
The first perfect number.
The number of platonic solids.
The number of sides on a square.
The number of understandable spatial dimensions.
The number points to define a line.
And the multiplicative identity.
On the eighth day of math class, Prof. Chang gave to me
Infinity sideways.
The number when you square root 49.
The first perfect number.
The number of platonic sides.
The number of sides on a square.
The number of understandable spatial dimensions.
The number points to define a line.
And the multiplicative identity.
On the ninth day of math class, Prof. Chang gave to me
The ninth digit in pi.
Infinity sideways.
The number when you square root 49.
The first perfect number.
The number of platonic solids.
The number of sides on a square.
The number of understandable spatial dimensions.
The number points to define a line.
And the multiplicative identity.
On the 10th day of math class, Prof. Chang gave to me
The base of our number system.
The ninth digit in pi.
Infinity sideways.
The number when you square root 49.
The first perfect number.
The number of platonic sides.
The number of sides on a square.
The number of understandable spatial dimensions.
The number points to define a line.
And the multiplicative identity.
On the 11th day of math class, Prof. Chang gave to me
The first double-digit prime.
The base of our number system.
The ninth digit in pi.
Infinity sideways.
The number when you square root 49.
The first perfect number.
The number of platonic solids.
The number of sides on a square.
The number of understandable spatial dimensions.
The number points to define a line.
And the multiplicative identity.
On the 12th day of math class, Prof. Chang gave to me
A dodecagon.
The first double-digit prime.
The base of our number system.
The ninth digit in pi.
Infinity sideways.
The number when you square root 49.
The first perfect number.
The number of platonic solids.
The number of sides on a square.
The number of understandable spatial dimensions.
The number of points that define a line.
And the multiplicative identity.
Wow, that was a great sponsor, was it not? Well, now that we're back here, we have the final decision of who won. So, wow, that was a unanimous decision. The judges believed that since we ended on such a great note, and she pretty much dominated the field in that one, our winner is Liz.